The warm-up's on the board. I actually want to do it together because this was a mistake that I saw a lot of people make on the test, and I feel like you guys should know better than what you're doing. So, shh. Class has started. The first one. How would you do the first one? Yes. Distribute the x. Good. So this would be 3x squared plus 1x, which is just x. Great. Now, how would you start the second one? What? Yes. Distribute the what? You do not distribute the 4 here. Why can I not distribute the 4? That's the mistake that everyone, not everyone, a decent amount of you were making on your test last week. You would distribute the 4. Why can't you distribute the 4? Yeah, x plus 2 times x plus 2. But yeah, you were pretty much right on. You cannot distribute the 4 until you take care of this exponent. It's basic order of operations. You don't multiply before you do exponents. You do exponents first. So we'll double distribute here. So we have 4 times x squared. That's going to be plus 2x, which will be plus 4x, plus 4. Then you can distribute the 4. So your final answer here is 4x squared plus 16x plus 16. This came into play when we were doing vertex form on your test, and people were messing it up. Now, another common mistake that I saw on the test a couple times, you would deal with the exponent first, but you do it incorrectly. You cannot just say this is x squared, this is 2 squared. It does not work like that when there is a plus sign. However, on this next one, that is what we're going to do. So it's going to be 4 times 2 squared x squared. Again, you cannot multiply through by the 4 yet because you have to do the exponent first. And here we can follow the exponent rules that we learned last week. So this is going to be 4 times 4 x squared, which gives us 16x squared. So just a little bit of a review on where these exponents come into play, especially when you consider the order of operations. Any questions on why we did a certain warm-up in a certain order? Alright, today we are doing section 6.3. It's all about adding, subtracting, multiplying, and... no, not dividing. I got on a roll there, sorry. Just adding, subtracting, and multiplying polynomials. Our goal, to add, subtract, and multiply polynomials. Originally on the green schedule I gave you, it said that the next day, after this day, we would do 6-4. We are not going to do 6-4 tomorrow. 6-4 takes 2 days to do. I don't want to break it up over a 5-day weekend. So we're just going to do 6-3 today. Tomorrow we're going to slow things down and go over your Chapter 5 test in class. So tomorrow will be kind of a review day, get everyone on the same page, and then we won't start 6-4 until after Thanksgiving. So just be aware of that. Alright, the first thing we're going to look at is adding polynomials. When you add polynomials, you just combine like terms. Whoops, too far. There we go. So, number 1, what are the like terms? The x squared's good, which would give us 9x squared. Then what? Good. -7. Good. This should probably feel like a review today. Hopefully you're thinking that right now as we're going through this. What about number 2? Negative 2x cubed. Good. Minus 1. Great. So, again, whenever there is a plus sign in between two polynomials, you can simply just combine the like terms. Any questions? Same type of problem here. You can see in the directions right above the directions it says adding polynomials horizontally and vertically. That's just basically saying if it was written vertically, it's the exact same thing. So they could write it like 4x squared plus x plus 6 plus 7x minus 10. You do it the same way, just combine like terms. Alright, so does anything go with the 4x squared? Nope, so just 4x squared. We can add our x's. 1x plus 7x is 8x. Positive 6 and a negative 10 is negative 4 or minus 4. Remember, as you're doing this, we always want your answer to be in standard form. So from the biggest exponent to the littlest exponent. So like on the next one, you wouldn't want to start with the 14 minus 5. You'd want to start with your x's. Also, don't forget this negative stays with the 6x. So what is negative 6x plus 8x? 2x. And then 14 minus 5 is 9. And it's positive, so plus. What questions do you have? Subtracting polynomials is a little more complicated than adding them. The reason is you are subtracting everything in the second set of parentheses. So I'm going to rewrite the first polynomial. Nothing changed. But now I need to change all the signs in the second polynomial. You're basically multiplying through by a negative 1. So it's going to be minus 4x squared plus 2x minus 1. And then now we can combine like terms. So 5x squared minus 4x squared is just x squared. Negative 6x plus 2x is negative 4x. And negative 1 and negative 1 gives us a negative 2. Questions? Same idea on the second set of parentheses, or sorry, on the second problem, second set of parentheses. So the first set stays the exact same. It's just 5x to the third plus 7x plus 8. Now I'm going to make it minus x to the third plus 6x minus 4. And then combine like terms like usual, starting with the largest exponent. 5x squared minus x, 5x to the third minus x to the third, 4x to the third. I don't have any x squareds. When I combine the 7x and the 6x, I get 13x and a plus 4. Any questions? This should seem like a review. Yes? No? Awake? No? Okay. Alright, more practice with subtraction. Don't change anything in your first polynomial. How would I rewrite the second one? Good. Alright, combine your x squareds. They're both negative, so I can add them, keep the negative sign. I get negative 10x squared. Nothing's going to combine with that x. And then my constant is 8. Same thing on number 8. Keep the first one the same. What happens in the back? Good, so I'll have plus and a plus. 6x squared. Nothing combines with that x. And then I get a 10 as my constant. What questions do you guys have? right now I have a monomial because it's one term times a trinomial because there's 3 terms. How do I do that? Distribute, good. Once we're done, we'll get 10 out of the way as well. So I need to distribute here. That gives me 3x to the third plus 3x squared minus 6x. Same thing on the bottom, let's distribute. So that gives me negative 2x. I'd have a plus 2x squared and a plus 2x to the third. Do I want to leave my answer like that? Yeah, you're essentially just changing all the orders right now. Yeah, the first one's going to go on the front, the first one's going to go on the back, because we want it to go from highest exponent to smallest exponent. Very good. What are your questions? All right, we looked at some similar to this last chapter, but it was always a binomial times a binomial, meaning 2 terms in each set of parentheses. Now we have a binomial times a trinomial. It's the exact same process, though. We just double distribute. So distribute the x first. That would give you x to the third plus 2x squared plus 4x. Now we'll go ahead and distribute the negative 2. So minus 2x squared minus 4x minus 8. So x to the third goes in the front. Then my x squareds. What happens to my x squareds? So no x squareds. What happens to my x's? Good. So we just have a minus 8. Great. Same thing on the next one. Double distribute, so 2x to the third minus 2x squared minus 6x plus x squared minus x minus 3. Nothing's going to combine with my 2x to the third. I will have some x squareds, unlike the last one. I'll have just 1, and it will be negative. For your x's, you get minus 7x, and then a minus 3. Oops. Questions? Alright, now you saw on the last slide the first example was actually a special product. Sometimes when you do the double distributing thing, some special things happen. Here's just a list of those special things. So the product of a sum and a difference. So you can see it's the exact same thing in the parentheses. One has a plus, one has a minus. That's where the middle terms always cancel out and we have a difference of squares. Now, if you can memorize these, they will definitely be a time saver for you, and they'll help you when we get into the bigger sort of factoring situations. If you ever draw a blank, though, you can always just double distribute, and it basically happens naturally. Here's an example. So if we had 2x minus 3 times 2x plus 3, when you double distribute, your middle terms would be plus 6x and minus 6x, so they would cancel. And you would just have 4x squared minus 9. Here's another special product. The sum of binomials, the square of a binomial. So if you have a binomial, like a plus b squared, it's going to be your a term squared plus 2ab plus b squared. here it is with some real numbers. So if you had the quantity 4x minus 1 squared, you'd square the first term. 4x squared is 16x squared. You'd multiply the a and the b and multiply it by 2. So 2 times a is 8x times the b is negative 8x. And then negative 1 squared is 1. Again, you could just write it out and double distribute. You end up with the same thing. It just kind of saves you some time if you can memorize it. Now, these are the new ones. You probably haven't seen these yet. The cube of a binomial. So if you have a binomial cubed, it's the first term cubed plus 3 times the first one squared times the second one plus 3 times the first one times the second one squared, and then plus the second term cubed. There it is with some numbers plugged in. So you can see that x cubed would be your first term. 3 times a squared times, oh wait, let me see. They're missing a squared, aren't they? Yep, you're missing a squared right there. Sorry. Because you'd square the x, so that would be x squared. The next one you'd have 3 times a, so 3 times x times b squared, so 3 times x times 16 gives you 48x. And then 4 to the third gives you 64. So sorry about that, just missing a squared. All right, so now we want to use those special products for these two. So for the first two, we're doing a sum and a difference. And then the next two, it's the square of a binomial. So when you have a sum and a difference multiplied together, what happens to the middle term when you double distribute? It always cancels. So we could just go right to the answer here. Anyone know what the answer is? Yep, x squared minus 25. Good. That one's usually an easy one to remember because you guys are used to factoring those. It's a difference of 2 squares. What about the next one, number 14? Good. 4x squared minus 49. Great. Do you guys remember how the next one worked out? The next one's one that students don't always memorize. They usually just write it out and double distribute. I do want to look at the memorizing option though right now. So this is usually whatever is in the x position squared. So x squared. And then you take 2 times this times this. So 2 times x is 2x times 6 is 12x. And then you just square the last term. Now, if you wrote that out and double distributed, this would be your final answer. It would just take you a little more time. So like I said, these are basically just ways to save time. Does anyone know, without writing it out, how 16 would work out? Well, it's always just your first term squared. Yeah?
Would it be x squared minus 6 minus 9?
You're missing one thing. x squared minus 6x, because it's 2 times the first term times the second term. So that'd be 2x times negative 3, which is negative 9x. Or sorry, negative 6x. And then you had a little mistake with your 9 too, because it'd be negative 3 squared, which is positive 9. So this is what you get. Again, if you wrote it out and double distributed, you'd end up at this same exact spot. What are your questions? All right, this is the one that I said is probably one you might not have seen yet. So let's kind of think back to what we learned. So your note said if we had something like a plus b to the third, what would we get? Someone read me what your note said. Started with an a to the third. Good. Plus 3 plus. Good. So that is what we're following. That's the pattern that we're following here. What is playing the role of A? What's in the A position? X. Good. What's in the B position? Negative 1. So we can follow right along and just replace everything with an X or a negative 1, depending on if it's an A or a B. So I start with A to the third, so that'd be X to the third, plus 3 times, that'd be X squared times negative 1. We'll go back and simplify. 3 times X times negative 1 squared plus negative 1 to the third. So I just rewrote it. All the A's I turned into an X. All the B's I turned into a negative 1. I kept the B's in parentheses to figure out what happens with the negative signs. So when I go through and simplify, the X to the third is just X to the third. We'd have to multiply the 3 and the negative 1, so this would be minus 3x squared. Here, though, the negative 1 is being squared, so that would be a positive, so just plus 3x. And then negative 3 times negative 3 times negative 3 is negative 1. Again, if you wanted to double distribute, you could. You'd have to double distribute a lot, though, because this would be x minus 1 times x minus 1 times x minus 1. So it would take you a while. This one's a lot easier to just memorize. What are your questions? Same idea here. While we're getting used to this one, I'll go ahead and write it out. What is playing the role of A? X. What is our B in this case? 2. Positive 2. Good. So I want A to the third, so that's x to the third, plus 3 times x squared times 2, plus 3 times x times 2 squared, plus 2 to the third. And then I can simplify. You got to square the 2 first, so that'd be 4. 4 times 3 is 12. And then 8. The cool thing about this is it's already in standard form. Nice. What questions do you guys have on this? It's basically just memorize the way it works out, plug numbers in, or just get used to double distributing and go from there. Questions? Here's your homework tonight. So you're just working on the odds on page 341, 13 to 55. All the answers should be in the back of your book. Bring questions tomorrow. We'll have some extra time tomorrow. All we're doing tomorrow is going over the Chapter 5 test and going over homework questions. So bring questions from 6-1, 6-2, 6-3. We'll have plenty of time tomorrow to work on those. You might actually have time to work on some old assignments if you haven't gotten them done yet. And then we will talk about your test. The goal is no homework over Thanksgiving. So hopefully you guys can get that all done by the end of class tomorrow. Any questions?